Testing, testing. All right, is that better? Okay. As I was just saying, I think we have all the technical issues worked out. What could possibly go wrong now? There we go. All right. Can we get a audio check? Testing, testing. All right. So, like I was saying, I'm here in my new shop. The streaming setup is not super great yet. I've only got the one camera, but I do have a new computer and I do have better internet, so hopefully it goes better than the last time we tried to stream here. So, just real quick, to reiterate a point, this is a box of parts that are currently a lot of parts and need to be fewer parts, now with more light. So I'm going to assemble all of this, and then this is the control electronics that I have. This is a Texas Instruments board that will provide the ability to drive the solenoids, and somewhere between there, hopefully we can get a functioning valve set as I walk backwards into my light. Oh, I know exactly what I'm doing, guys. There's nothing wrong with this at all. Okay, so I guess it's just kind of time to get started. So this is a box, or bag rather, of gaskets. So these create the seals in between the manifold and the valves. These are all the valves themselves. And this is the 5-way solenoid valve manifold. And this is the 3-way solenoid valve manifold. And then these are blank-off plates for places where I don't want to install valves. Okay, so what does that mean? I think the first thing to do is just going to be to crack some of these open and just show off what I'm talking about. Here we go. So all these components are from Automation Direct, and they charged me a real pretty penny for it, but essentially this is what I've got. So this is a 5-way solenoid valve. So this will drive this, which will be hooked up to this, and this is going to be what one of my main propellant valves looks like. So essentially what happens is there are 2 ports here and here. These are British standard tapered pipe threads. So I will connect fittings there and then run hardline, so like bent aluminum tube, like this assembly kind of, that will connect these 2 ports to these 2 ports on my solenoid valve. So what happens is that when there is no signal to this solenoid valve, there is no pressure being delivered to either of these ports, and the valve doesn't move. When I fire this valve, pressure would go in this port and open the valve by turning this stem right here, using an adapter that connects this key to this set of flats here. And then when I let go of it, the valve will stay in the open position until I apply power to this solenoid, which will open this valve here and allow pressure into this port over here, which will rotate the valve the other way. And then both valves, when they switch configuration, they will vent out here so that there's no back pressure that the other solenoid has to work off of. This is a rotary pneumatic actuator from SMC Motion Components. It's gas countersprung, so by adjusting these screws here and here, you can control how long it takes to open and close. I don't particularly care how long it lasts for, since this is designed for like industrial automation, a lot of cycles, so I'm going to just basically back these all the way off so it's opening and closing as quickly as I can. I have one other kind of valve that we'll be working with that I've just put up there. This valve is a spring return single-acting pneumatic actuator, and this is for the gas pressurant. So essentially what happens on this one is that when you apply pressure to one of these ports here, there are two pistons on racks and pinions that slide apart, pushing against springs here and here. And as those slide this way, gears on them turn a gear on this shaft here, which opens and closes the valve. So this is really nice because this is even easier to drive. It's lower force, but you only need a single valve, so it will fail closed, which is great because that means that if the test stand loses power, the tanks will depressurize instead of pressurize. Although in this case, this is a two-way valve, so I think this is meant to be for my purge line. But you can see that this is much simpler to control. This only needs one of these components. So a single valve, three-way, so when you power it up, it connects this side to this side, and then when you depower it, it connects this side to this side, allowing the pressure out, allowing the springs to push it back closed, rotating the valve stem again, closing the valve. So this is for my purge line on my engine. So after engine shutdown, I will run a bunch of nitrogen gas through everything. That'll clear out any remaining propellant and keep it from burning after everything is said and done. All right, let's go to the chat because I haven't read the chat yet today, which seems like a good thing to check. Okay, Astro Chuck is a beast. Thank you, Jordan McMillian. I owe you an email, I think. Nathan Webb, why is the 5 smaller than the 3-way? The 5-way actually has 2. So this one, there's a wire coil here and a wire coil here that's moving 2 separate poppets in and out to control the airflow. On this one, there's a single coil here that moves a single poppet right there to control the airflow. And these are actually really light, maybe 30 grams, so these are not very heavy. So the weight to power density is actually quite spectacular. Okay, your first robotics event just got canceled because of coronavirus. I'm very sorry to hear that. There's a lot of that going around the world right now. Just a friendly reminder, wash your hands, only purchase what you need so that the supplies are available for people who need them as well. And practice social isolation to the best of your ability to help protect those who are potentially more susceptible to the virus than others. Let's see. Finals are postponed indefinitely because of COVID-19. Well, I guess you win some, you lose some. Is your rocket engine going to be large enough that you need to make accommodations for combustion stability? Andrew, yes. I am highly suspicious of combustion stability. Just 1 second, folks. All right, sorry about that, folks. New phone, and I don't have contacts on it yet, so I didn't know if that was an important call or not an important call. But it's not an important call, so we're right back. Okay, is the engine going to be large enough that I need to worry about combustion stability? Yes, Andrew, it's definitely going to be a problem. I'm hoping that by my selection of a pintle injector, I will have both limited susceptibility to combustion instability, as well as the necessary space to tune acoustic properties of the chamber, should that be necessary. But I'm definitely at risk for that. Emin Keywall, you thought the project budget was like 4K. 4K was a long time ago, and when I had a part-time job instead of a full-time job and was still finishing up my concentration in political science. The project budget is now much larger than 4K. I think this was $400. I think each of these was $55. The 1-inch valve you saw a minute ago was like $100. The regulators have been by far the most expensive part so far. Each of those was like $550. And I'm still scourging eBay for good deals on stuff. This is just not going to be a cheap project. Okay, let's see. If the valves close almost instantly, will there be a problem with the water hammer effect? Merlin, there definitely could be, but as a separate feature, I need to include a gas accumulator right near the valves, so that will help take up the effects on that. Let's see. Charlie Industries to take on SpaceX. Charlie Garcia Systems, and no, I will not be taking on SpaceX. I know exactly how smart every other person at SpaceX is and have no desire to find out whether one person or 7,499 people are smarter. Spoiler alert, it's them. Okay, let's see. That is, I think, most of the interesting stuff, so let's start bolting it together. All right, this needs out of my workspace. So I think the first thing we're going to do is we're going to do the three-way valves. So this is the manifold. So if I go ahead and open this up, here we go. So just for the record, folks, I've worked with pneumatics some before, but this is my first time with this company using any of these products. So it's going to be a little guess and a little check, and we're going to see if we can figure it out on the fly. But I suspect the first thing to do is going to be to take off the wrapping and throw that in the trash. Okay, so this is a manifold, just kind of looking at the notable features. It appears that we have inlet and outlet ports, so I suspect this is going to be for supply pressure, this is going to be for vent pressure. And then we have a bag here full of gaskets. And so what happens is that while the valves are threaded on the underside to take NPT fittings, I really don't feel like hard lining all of these valves together with a bunch of T-fittings. That seems both more expensive than it needs to be and more work than it needs to be. So they have devised this way, so you put a piece of rubber between it and you bolt them down like this. And since these only run at like 110 psi, that is sufficient to keep the air pressure in. So if we pull out one of these gaskets, it appears that there is a 3D-ness associated to these gaskets. And if I had to guess, I would say that the raised features go down. Yes, the raised features go down. Determined by trial and error because it doesn't fit the other way. So then this goes like this, and then is that going to be those screws? I don't know. Let's find out. Obviously, the first step of any project is just to dump all your parts out on the table. Anyone who's good at building Legos will tell you that. Just cut all the bags open, ignore all organization, and just dump it. Dump it all out. I was thinking, they came out with the new LEGO ISS. I kind of want to do a LEGO ISS build sometime on stream. We'll see. I have to actually like have free time first. Okay, throwing all of this away. Trying to keep a tiny workspace. So, what is the feature on these? These are Phillips, which scandalizes me. If I'd known these were Phillips, I would have bought bolts that had hex heads, just so I didn't have to work with Phillips. But we're just going to go ahead and... there is also an order associated with this. How do these pop together? Oh, they don't. Okay, so those are raised so that they get squeezed. I see. Okay. So what I was trying to find is I was trying to find these little raised ridges here to like detent into that point there, but they don't. They sit on this surface to seal. So the sealing surface is this surface right here. So I'm going to grab a Phillips head screwdriver, and I'll be right back. Yep, and I just killed the light again. Don't worry about it. I'm going to get this fixed soon so that this is less awful. All right, back to the chat for a second. T-minus 16 hours to MIT decisions. Nathan, good luck. I will say what I always say, which is that if you could succeed at MIT, you can succeed anywhere without MIT. So don't worry too much if you don't get in. If you do get in, congratulations and on your hard work, and you should definitely join the MIT rocket team. Ismail, am I building a full rocket or just an engine? For now, just an engine. Stay tuned, though. If the engine works, we can start talking about the rocket. How many injectors are going to be in use on the engine? There will only be a single pintle. Ian, how big does an engine have to be to risk combustion instability? To be honest, I have seen combustion instability on engines down to like 100 newtons, so I actually don't know. The answer is you can definitely have combustion instability. Charlie, have I had any trouble with ITAR? I would if I did anything export controlled, which I'm going to studiously avoid doing, just for the sake of all of us having a better time. Okay, Ammon Keywall, you're not sure about specific limits, but it does have to do with the overall amount of power it produces. So just for the record, if you're going by thrust, this would be an export controlled engine. I am not doing anything outside of the scope that you can find in a textbook or a college education, therefore I have access to specific exemptions. Let's see, how much have I already spent, and how much will the engine be? I would rather not disclose either of those numbers, but the answer is about $5,000, so certainly not being paid for by YouTube money. Okay, that is about the interesting things. Brandon, there aren't any legal concerns that I have yet. When I get around to testing it, there certainly will be a few hoops to jump through. So we're just going to go ahead and drop 2 of these fasteners in, and we're going to see. I really don't want to overstate my prior experience with this, so I am kind of winging this. There we go. So that's seated really happily. It made a happy sound. So this is a case where you definitely want to tighten the bolts in a pattern so that you don't overstress one side of the gasket. You want to take it down evenly. Okay, so that's that. We're going to take this opportunity to pop this cover off and show you how this gets wired up, which we will do kind of at the end. So this is the connector here. It's got 3 blades that make contact with these 3 ports right here. And then this is a dropped part is what that is. That's a dropped part. But if I undrop it, this is a DIN, see if I get a little closer to the camera. This is a DIN 11 wire fitting. So it screws in to grab a shroud around the wires to protect it. So we can take the screw out from the top right there before I drop another part. And then I can grab a little thing to pry that out, and I can show you how you wire this up. Okay, so we're just going to take this and pop it under and get this out. So here you have the wiring block. There are 3 screw terminals, one there, one there, and one there. And those are how you put the wires into it. And then you just route the wires out through the hole. You get the shroud grabbed by that DIN 11 connector, and then you're good to go. And it helpfully says on each of the on the PCB up here, it's not focusing, but it says exactly what wire goes where. So you need 3 wires. You need a DC positive, a DC negative, and then a shield wire. So you can also, that means you can flip the connector around so that you can wire it, instead of just having to wire it this way, you can also wire it, say, that way if your control scheme required it. You can also take the whole solenoid backing off and rotate it down and put just a row of these connectors down here. But for now, we're just going to stick with the default wiring scheme because I'm lazy. So we'll put that back in there. We'll put that back in there. And screw it all back together. All right. Chris, what is export controlled for injectors? The impression that just about everything is export controlled is probably not an accurate one, since there are specific exemptions for information that is in the public domain, and the ability for someone to Google the TRW Pintle Design Handbook and access it from anywhere in the world probably makes it considered public domain information. Let's see. Do liquid engines have any problems at different G loads? Yes, Chris, that is part of a combined loads analysis. The fluid dynamics changes, the head pressure changes. That can definitely be a factor to consider when designing flight engines. Let's see. Ian, when trying to get information on mine that I was working on, the hardest part was injectors because it seemed like they were so heavily regulated. The honest answer is that a good injector is just a little bit of black magic, which is why I won't be publishing design specifics for mine, and very few other people will, and you just kind of make do with what you've got. Let's see. MD, are you going for an all-solenoid setup on the test stand? I don't know what you mean by that. If you're asking if there are going to be any motorized valves, hydraulically controlled valves, or electrically controlled valves, the answer to that is no. I changed my mind after going to all the trouble of designing and building my own electrically controlled valve. I'm like, wow, this is awful, and still doesn't produce enough torque for like cryo valves. So I'm just going to abandon it, which was probably a good idea, and I should have done it before I went to the trouble of designing an electric valve. Let's see. Brandon, I do have a Patreon. Maybe someone will be polite enough to link it in the chat. Let's see. MS, keep it simple, stupid is not lazy. You are correct, but being lazy sometimes is also an equally good strategy. Okay, Noah, do I know anyone looking to hire a propulsion engineer? Not right now. I know places doing internships. Blue and SpaceX are kind of always hiring on a contingency basis. Aerojet hires sometimes. Ursa Major maybe. I don't know. It depends. It also depends if you're like looking to do like electric propulsion, which is definitely more in demand right now. So if you're willing to work on ion engines, I think you probably have an easier time finding a job. Okay. Would combustion instabilities happen when there's a difference in atmospheric pressures? Josh, I don't really understand what you're asking there. Can you try rephrasing it? And in the meantime, I'm going to open up another solenoid valve. Otherwise, we're going to be here all night and get, like, actually nothing done. So just popping open another one and into the recycle. Oh, this bag is already helpfully open. So this is another one of the three-ways. So we will grab one of these, put it on there. What is everyone else doing tonight in the world where everyone is working from home and all sporting events are canceled? Let's see, there we go. Just for the record, this is why it's never a bad idea to, if you have the resources, pay for hardware. Because even though I spent a lot of money on these, it is already fitting together better and with less work than a lot of other home-built parts that I have put together, which is the miracle of capitalism. When it works, it works. And if it doesn't work, you go out of business. Okay. And the next one. Have I found it difficult to find enough online resources for how to build a liquid rocket engine? To be honest, I kind of know the theory of building a liquid rocket engine, and I know some of the practice from previous projects. So the things that I am discovering, i.e., like how to build a liquid rocket engine, are the minutia of how the specific choices I'm making on this project were either good or bad choices. Although in general, the internet is not as helpful for building liquid rocket engines as you would like. Partially that's its background in defense technology, but partly that's also just that there haven't been a lot of educational content regarding it before, and hopefully this fixes that to some extent. All right. There's probably supposed to be torque values associated with these bolts, and I'll come back and make sure they're all to spec later when I have a torque wrench. Aiden, metal casting is super cool, and I would actually love to try and cast some of the parts for this engine. Particularly if I go with the nozzle that I'm going to machine and electroplate myself. I think it would probably be wise to try casting the blank before I turn the nozzle. I think it would save me a lot of money. But that means I have to get a casting setup all put together, and copper is not the easiest material to cast. So we'll see. Let's see. Adam, I cannot advocate for getting less than 8 hours of sleep a night, although I'm guilty of it often enough myself. Let's see. Snorting hand sanitizer, also not recommended. Josh, I actually don't know if an altitude difference causes different combustion instabilities off the top of my head. I would suspect the answer is no, if nozzles work the way I expect they do. But I wouldn't want to categorically state that. There may be esoteric secondary effects that make it so that it's not just the back pressure, which is set by the throat dimension, which is affecting combustion instability. Here we go. Get that seated. Merlin, go to sleep. I mean, you can keep watching if you want to, but go to sleep. Let's see. MS, am I using weather-resistant electrical connectors? Actually, yes, I will need to shield all of these wires. I don't know how to exactly yet. If someone wanted to find DIN 11 size cabling for solenoids that I could just buy a roll of, that'd be cool. Otherwise, I guess I'll make my own. Let's see. Hernandez, I have seen you around. You were on the stream with Joe on Monday. Was that Monday? I think that was Monday. Let's see. Aiden, I'm not a big fan of hybrids, so if you want to build a hybrid, be my guest. Just don't come crying to me when it doesn't work very well and sucks. Not saying that your design will suck, just that I take personal offense at hybrids for being both the worst parts of a solid and the worst parts of a liquid. Let's see. Mark, what do I think about 3D printing engines? Well, that was the original plan for how I was going to make this engine, was I was going to 3D print the nozzle. That turned out to be a stunningly expensive idea, like $7,000 just for the nozzle. So I either need to make the engine a little smaller, or find a friend who wants to print it for me, or not have it printed. But printing will definitely be useful for a lot of parts on this engine. And for smaller engines, I think there's definitely a reasonable expectation that you can now print most of the parts of a small engine, which is in fact my day job, which is kind of cool. So probably can't say too much there, but I work on some cool stuff at my day job. Let's see. That is that. All right, so just once again, the gasket with the 3D features down, the bolts through it, and then I set the solenoid valve on the manifold and just kind of wiggle it around till the features on that gasket drop into their holes, and then I just do one bolt, and then I rotate it till the second feature drops into place, and then I do the other bolt, and then I just kind of tighten them evenly so that it doesn't crush one side of the gasket too much. Just for the record, this is like a really satisfying chunk of hardware to hold. I've been buying parts for this engine for like months now, and it's just so frustrating because the parts are like so far apart on the engine that I can never just like put something together and proudly say like, look, I built this thing, just because the parts are all so far apart. And when this is done, like this is one, the largest chunk of hardware I have assembled right now, and two, it gives me an opportunity to actually just like put hardware together. It's like a really especially frustrating thing to be like well over $5,000 into a project and still not have actually like put anything together yet. But that is changing rapidly. I'm working on the CAD still. Maybe I have like a week left, maybe a week and a half left on CAD for the test stand before I can order the structural plate to be water jet. But once I have that, then I can start putting parts onto the water jet plate, and that's the like structural backbone of everything. So once that happens, then it can really start coming together, and I can start testing stuff and checking for leaks and whatnot. All right. There we go. Let's take a break, read chat, and figure out what the next steps are from there. So I'm going to turn all of my camera stuff around and get a bench. Cheers. Now I can't see the chat. Let me turn this. Ooh. We're good. Okay. Wow, that is actually not that great. Give me 1 second, folks. I'm going to get a different chat tool. All right, folks. I'm back with a closer chat and a beer. So, now to actually check the chat. Wow, I missed a lot. Okay. Have I ever had hardware I designed in space? Yes, I have had hardware I designed in space. It was very cool to have hardware I designed in space. Have I thought about using a carbon fiber engine? No, I do not like the idea of a carbon fiber engine. It's applicable in some circumstances. I think it's a poor choice for me. When I test my engine, will I live stream it? Maybe. I haven't quite figured it out yet. It's too big of a job for me to test the engine and live stream it, so I'd probably only do it if I could get a friend to come out and help me. Would you say that aerospace engineering is control heavy? At MIT, you can pick your subject specialization inside of aerospace engineering. So you could do, say, propulsion or structures or control theory. So I definitely have friends that did very control-heavy degrees. I myself did not. Okay. Do I know why the linear aerospike design hasn't been picked back up in the mainstream? Honestly, aerospikes are kind of crap. When I was helping Tim with the aerospikes video, I kind of wish he'd been like more upfront about the fact that aerospikes suck. Which was the original title for the video, I think, was Aerospikes Seriously Suck. I actually have an Aerospike video that's like 85% made. I have to finish editing it because I kind of ramble in the middle about what simple and complex regions are for method of characteristics, which honestly I think most people probably don't care about, and it really like makes the video like half an hour long and no one cares. So maybe I'll finish editing that up this weekend, possibly. We'll see. Has MIT ever made a turbo pump on the rocket team? No, we haven't. Turbo pumps are hard. I'd love to work on one. When I get the engine working, I want to like try just adding a turbo pump to it. Apart from Sutton, what are other good textbooks for rocket propulsion systems? Well, you have to read Husel and Huang, which is the like canonical text for small rocket engines. There was one textbook, I don't remember who wrote it, was called Propellants and Explosives. That was a fun read. And by fun, I mean in the way that like textbooks are fun. In general, any of the like NTRS papers written in the 60s will be useful. Yeah, I don't think there's like another canonical textbook. I think once you get the first one done, then you just kind of read whatever you need to read to do a certain thing, whether it's like read a SEAL design handbook or a SEAL design textbook if that's what you need, or turbo machinery handbook, whatever it is. Would a ceramic coating on the inside of the nozzle work as a heat insulator? MS Posey, you can definitely use a ceramic as a heat insulator on the inside of a nozzle, and I know this because my first engine had a ceramic liner on the inside of the nozzle, and it had no cooling other than the fact that it was a giant chunk of metal and it had this ceramic coating. It depends. I mean, sometimes it's appropriate, sometimes it's not. Wow, I'm barely keeping up with the chat here. What flow cycle type is the engine? This will be a pressure-fed engine. No fancy cycle. I could see the SENES. Never mind. Okay. Is the engine pressure-fed or is there a turbo? Definitely pressure-fed. Let's see. You like the logo. Thank you for liking the logo. I made it myself. I think it's appropriate. Let's see. Is this Blue Moon beer? It is Blue Moon beer. They didn't endorse this video or pay me to say that. So, Blue Moon Brewing, if you're watching this, 1, you should send me sponsorship money, and 2, you should send me a version of that keg you made after the Blue Lunar Lander event. I actually called them and asked if I could have a version of that keg so I could put rocket engines on it and make it fly, and they told me that unfortunately they only made one of those kegs. Where am I going to test my engine? I will test it at a test site. I have a test site. It is safe and used to test other rocket engines, and I'm not sure if I should say more than that. Let's see. Can I give more details on the hardware I have had in space and how high it went? It has been both. I have had hardware go both orbital and suborbital, all with SpaceX, and it's done cool stuff. Yeah, pretty proud of that. And I will have hardware, hopefully. I haven't been at SpaceX in a while, so I don't know if it's still this way, but I think I will have hardware flying on the Demo 2 mission, which is exciting to me. You know, sending people back to space and all that. Let's see. You would love to see stuff about method of characteristics. Well, you're in luck. I have like a 35-minute video that I need to finish editing. Let's see. I actually intended to publish the video at the same time as Tim Dodd's Aerospikes video because I did a lot of math to help him do that video. And really what happened was I kind of got into a hectic part of my life while moving and like finishing up my political science concentration, and I just didn't finish it. Let's see. What was that small rocket engine textbook called? It was called, Design of a Modern Small Bipropellant Engine by Husel and Huang. Just Google like Husel and Huang, and you will find it. It is everywhere on the internet. Let's see, electric turbo pump the trend now. Electric turbo pumps are awesome because you don't have to design turbo machinery. Well, you don't have to design all the turbo machinery, you just have to design the pump, which is the useful part. Turbos are like art unto themselves, especially because rocket engine turbo pumps, like rocket engine turbines, are typically single-stage impulse turbines as opposed to like multi-stage reaction turbines you would see in a jet engine, so the number of design resources are also limited. Also, they get like really stinking hot. Let's see. Aiden, what was my first engine made out of? What metal? Well, it was made out of brass and aluminum, and I think I have it up in some of my liquid rocket engine videos. I show it off. It's just a desk weight now. It did never work very well. It had a McMaster car garden hose spray nozzle as the fuel injector, and it did gaseous oxygen injection. Noah, I actually don't know any like hiring manager type folks. I know my old bosses at SpaceX, and I didn't do propulsion at SpaceX. So you probably shouldn't send me a resume. Sorry. Okay. So that was a lot of talking. Now, let's think about what needs to be done next. I have another manifold that needs 2 5-way valves done on it. I need to dig through my box of fittings and find 2 1/4-inch NPT plugs and probably NPT fittings to hook up the valves to some variety of supply pressure. And I need to wire everything up, and I need to test it. So thinking about that in order, going backwards, probably can't test it tonight because, speaking of new shops, I don't have a single roll of PTFE tape or Teflon tape in this shop yet. So I can't seal any of my NPT fittings, which is bad, and I should have fixed that before I did this stream. My soldering iron is also broken. I don't know why. I have to open it up and root around and see what's up. But it is kind of like a cheap Chinesium one, so it doesn't surprise me very much that it's broken. So I guess I could do like crimp connectors, and we could wire it up and I could try and boot up the board and see if I can drive any of the solenoids. And then obviously we can do the mechanical work on the second block of valves. What if that sounds interesting? Merlin, thank you for dropping the name of that textbook in the chat. Let's see. The other thing I will do, because it was requested earlier, and I am a shameless sellout who is not getting beer sponsorship money. If you would like to send me a beer, you can use a super chat, or you can join my Patreon, which I will link in the chat. MS, I absolutely hate the paste. It's just, it makes a mess. Let's see. Would I recommend powering a turbo pump with a brushless motor? That, as with all answers to all engineering questions, depends. For a very small turbo pump, you could probably get away with it. For larger turbo pumps, you have both efficiency concerns and cooling concerns that you need to keep in mind. And it could still be appropriate to use a brushless DC motor. I don't know. You need to... There's no categorically correct answer. Nathan, I probably should hop in Discords more often. However, I have a finite option of what I can do with my life, and I work a day job for 10 hours a day. So after that, I either work on liquid rocket engines or I like talk in Discords. So maybe I will. Let's see. Brandon, do I think that there should be a website for everyone about homemade rockets? You know, Brandon, I will demur on that question, and here's kind of why. The thing with rockets is that they are actually hard and they are actually dangerous. And part of the reason there are so few rocket engines is that the information is not easy to find, and this sort of self-selects people that have bad ideas. And just kind of categorically, everyone's first idea to build a liquid rocket engine is a bad idea. My own ideas included. And it is through hard work, lots of reading, and careful refinement that they become less bad ideas. And I'm not convinced that you could ever like write a tutorial that is verbose enough to impress upon people that what they are doing is dangerous, and penalty for messing up could be like a loss of fingers, limbs, or life. For example, right now I'm working on my ignition system for my rocket engine. I want my engine to be able to relight in flight, which limits the options of injectors I can use, especially because I'm not using dual cryopropellants. So I can't do like a gas-gas tap-off type thing. And I don't want to fly like a gaseous oxygen cylinder and a butane tank just to run an augmented spark igniter. So I was really thinking like it'd be very cool if I had like a hydrogen peroxide or a triethyl alumina tank that would help me light my engine that I could just open and close a valve to restart the engine. And so I'm working with some really absolutely awful chemicals, trying to get that system working. So I have some catalysts. I have some things that are like straight 4s on the fire diamond. Yeah, so I mean, if that information were easily available and it were easy to buy those chemicals, more people might be like, hey, wow, I can just like throw some high-test peroxide over a catalyst bed and I too can have my own rocket engine, and then they do it wrong and they're really hurt, and I would feel bad about that. Okay, you wouldn't happen to know how them fancy rocket guys make the catalyst pack on the hydrogen peroxide kerosene engines. I don't know who those fancy guys are, but I do know how to build a hydrogen peroxide catalyst pack, or a hydrazine catalyst pack, or several other types of catalyst packs. More on that may be coming in a episode of Liquid Rocket Engines, circa like episode 12. I think I'll get the igniter working before I get the combustion chamber working. Okay. MS, I don't care what your physical abilities are, your mental abilities are the ones in question. So if you know enough to safely design and build a rocket engine, or possibly better, you know you don't know enough to design and build a liquid rocket engine, then you are starting in the right place and can work from there. Alright, let us mosey in the general direction of putting together the next block of valve drivers. I think that's a good place to start. Alright, give me a second to get the camera turned around, I'll be right back with you. All right. Here we go. Back at the workbench. So this is the manifold with the 3-way valves, with the vent, with the supply line and the vent line. And then these are the activated lines. These are the common legs that run to all of the stuff that needs solenoid power. And then we've got this 5-way and this 5-way. There we go. Excellent. Okay. What are the downsides to an alcohol peroxide bipropellant engine? That's an easy one. You can't get high-test peroxide, at least not easily in hobby quantities. So what I'm really saying there is drink water, and also what I'm saying there is people who build hydrogen peroxide liquid rocket engines typically have both a rocket engine hobby and a peroxide brewing hobby. And so if you don't want to also have a peroxide brewing hobby, you should not use hydrogen peroxide as your oxidizer. So I know Copenhagen Suborbitals tried making their own hydrogen peroxide and decided not to do that. I want to say there's some other hobbyist building a liquid bipropellant rocket engine that uses high-test peroxide. But I want to say Paul Breed, but that may not be right, so don't quote me. But yeah, so definitely, I think LOX is just objectively the best. LOX isn't detonable. It doesn't, it's easily available. It's like $1 a gallon. LOX is amazing. Merlin, good luck and Godspeed on your L1 cert. I think the certification program is a great idea for amateur rocketeers. I will risk it and show you another project I'm working on. Just don't mind as I spin the camera around here. There we go. You can't see all of it. You may not ever be able to see all of it. This is a 4-inch O3400 powered, mostly COTS rocket. It's flying on a full 6XL 98mm motor. Really a fun project. It's a reflight of a rocket I flew in 2017, just kind of because I hadn't flown a rocket in a while. So this is a relatively accessible project. Just kind of interesting, worth noting. And back to this one here. Okay. All right. Cosmic, if handling LOX is hard, I hate to break it to you, buddy, but building a rocket engine is not going to be your thing. LOX handling is pretty much the easiest part of making a rocket engine work. So I did a dumb, and I didn't realize this was dumb. I ordered a bunch of backup gaskets, I guess, because I didn't realize that the manifolds came with gaskets. So I have spares for everything. So I'm going to assume this goes together the same way, where Oh, I've gotten it wrong. I lied to you all. When I explained this is the vent leg and these is 2 supply legs, I was wrong. This is the supply leg and these are the vent legs. So there's a common supply, and then this is a vent for this valve, and this is a vent for this valve. I don't know how I got it that wrong. I am supposed to know what I'm doing here. So this fits up, this sits down because that's the only high pressure side. So then we grab these bolts, pop them through. And now, just like the last time, we have to figure out which way around it is. I think it's this way. And my justification for that is that there's a slight diagonal slope to it. And I think that's how the diagonal sits. So we're going to try that. And we'll see if I got it wrong, we'll know when it leaks all over the place. Wow. My fine motor control is apparently suffering today. Like that. You know what? Wow, that is really unhappy. Are they supposed to be that unhappy? I'm going to bet no. I think I have the wrong screws. That has to be what that is. That screw did not go in far enough. Did I get the wrong screws for everything? I'm going to try opening these little kits and seeing if these screws are a better fit. All right, looking for explanations in the chat. Why don't the screws fit? Wow. Okay, these screws fit just as tightly, and I know the second bag of screws are right because I ordered them on a part number basis straight off the data sheet. So that means that either the wrong thing has been shipped to me or that is an intended behavior. Is anyone smarter than me in the chat with an answer? Let's see. Cosmic exploration, HTP will also combust rapidly when exposed to steel. All strong oxidizers need to be used with corrosion-resistant, explosion-resistant, non-catalytically active materials. Let's see. Ian, I mean, don't make explosions at home is good advice. I still have scar on my face where I can't grow facial hair because I blew up a rocket motor. First one I ever built. I didn't know what I was doing. So I think there's good wisdom in, if you can, join a local Tripoli or National Association of Rocketry Club. There's a lot of mentors. They'd be happy to help you. And that way you're not doing it at home. You're doing it with someone who knows what they're doing. Okay. Brandon, this is called a manifold, a solenoid manifold. So this is a solenoid valve. This is the manifold. There's a little gasket right here. This is the coil, and this is the connector. You know, Mark and K9 and everyone's saying they're just the wrong size. They are a close enough fit that I'm not sure they're the wrong size. Like, it would be incredibly esoteric if these were the wrong size. Because they're just like so, like, they're not like 20 thou off, they're like 2 thou off. Like, I could force it. But they just, I feel like they shouldn't have to be forced at all. So clearly the problem here is we have class 3B threads in what was supposed to be a class 2B threaded application, and the loose tolerances on this, I'm just making all that up. Those are actually classifications of screw threads and the tolerances and how tightly they fit. But I couldn't tell you at all if that is why these were not fitting correctly. Actually, if I had to take a guess, it might be there's powder coat in the holes where the screws are supposed to go. Maybe that's why. Also, this is like damaged. Maybe that's like the wire they had it on when they did the powder coat, but there's definitely like a deep scratch in the inside of this hole. Well, quality control miss. What can you do? That ain't right. That, on the other hand, is right. There we go. This one honestly fit so much better. I don't know why the other one fit so badly, but we're just going to try it. Holy cow. All right, we're just going to take these out and we're going to see. Maybe I've got like rubber in them or something. I don't know if you guys can see that. I don't see any particular reason why it shouldn't work. I could go chase it with a tap. I'm hesitant to do that without knowing why they don't fit. We're just going to try one more time. That seated there. You know, I know exactly how to fix this problem. Bigger screwdriver. All right. 2 solenoid valve manifolds done to like certain definitions of done. Wow, that was a great view of my elbow, guys. Just absolutely excellent view of my elbow. All right, I'm going to stop messing with that before I ruin the gasket. I think the next thing to be is going to go search through my box of fittings and find the 2404 unions that go 1/4 inch male NPT to -4AN. All right, here are my boxes of fittings. These are all parts, various places on the engine. These are the fittings for the instrumentation. These are -16 tube nuts for the fuel side. These are tube sleeves, also for the propellant side. These are 1 inch NPT to -16 AN unions for connecting the main propellant valves to the -16-inch run lines. This is a T-fitting that goes right below each main propellant tank, as this is what my capacitive LOX level sensor will stick up through, and then the main fuel flows out that way. More -16-inch tube sleeves. These are 1-inch NPT to NPT fittings. I think these are for connecting my check valves to my valve, so I'll just show you what that looks like real quick. Just a quick disclaimer, neither of these parts has been oxidizer serviced yet, so I definitely couldn't leave this together for testing. But when I get there, this is a check valve. It only allows flow through it in one direction. This is in case something really bad happens on the test stand to keep an explosion from propagating back into my main tanks. If you look inside of it, there is a this structure here, and then there's a central spike that has a spring on it that pushes a poppet this way. So when flow goes this way, it compresses the spring and flows out that way. But if flow tries to come back this way, it pushes against the poppet, and the spring pushes the poppet back into place, and it seals. So this goes just downstream of the main propellant valve. So this threads together right here. And these are tapered fittings, so you really need a big wrench. You have to rail down in it to get them to go home. But just kind of so we all get an idea of what this is going to look like. So the fuel tank would be back up here, and then this fitting here, and then this check valve here. And then this is where my purge line goes. So I'm actually going to drill a hole right here and put a 1/4-inch NPT fitting right there that's connected to the the single-acting spring-loaded pneumatic valve I showed you earlier, so that when the engine shuts down, nitrogen or helium gas will come in here and push everything down and out through the check valve, and then flow can't come back up through the check valve. And that just keeps everything in the engine nice and clean, and that way I don't have any propellant laying around where I don't expect it. Because everything back up here can be unloaded via the fill-drain valve, which is convenient. So this way I don't have any trapped propellant in the engine. So that is one of the fuel feed assemblies. So then I'll have a -16 flex hose made from stainless steel rated to 1000 psi that will connect here, and that'll run to the top of the engine, and that'll be where the that'll be what bends when the TVC moves. Here we go. This may be exactly what I need. Bingo, found them. So this is a 2404-04-04 fitting. It is an NPT that is a tapered pipe thread to a 37-degree flare fitting, sometimes called AN or JIC. And this will thread in right here. Once again, I need Teflon tape to do this for real. And then this one goes here. There we go. So that goes there and there. And then, here we go. These are the weirdest things ever. For some reason that I don't know, my pneumatic actuator is tapped with BSPT. So these are special just for my double-acting valves. So grab one of these and one of these. This is my pneumatic actuator here. Pop these caps off. So these fittings are also tapered fittings, but they're 1 TPI less than the NPT fittings, which means that they're just not compatible, and it's very frustrating. I popped the cap off the wrong side on this one, which is why it's not going in. There we go. Yeah, so then I've got this and this, which will be connected via tubes to this and this. And by applying electrical signals here and here, I can make the valve do this or this. Anyway, so that's the high-level overview of how this whole liquid rocket engine thing is going to work. And by turning the valves at the right time, I can, in theory, make it do what I want. There's definitely some in theory and in practice there. But yeah, so more chat, I guess. Is that the order of business? Let's see. Oh, what have I missed? I've missed a lot. Okay. Hydrogen peroxide is extremely dangerous. Yes, hydrogen peroxide, especially concentrated hydrogen peroxide, can be very dangerous. Only use it if you know what you're doing. And kind of by definition, most people don't. You can't wait to hear the satisfying clicks of all the solenoids. Neither can I. I have been waiting for many months, almost a year at this point in time, to hear this engine do anything. I'm still working on some control software. By working on it, I mean thinking about it. And by thinking about it, I mean I have no idea what I'm doing, so I'll figure something out. Johnny Hyman had some really cool software a ways back for his hybrid engine project that I kind of want to see if I can use. I think he made it open source. Charlie, did I try and keep all those NPT fittings NPT, or do I have a ton of adapters? I have a ton of adapters. And the reason I have a ton of adapters is because this is the eBay rocket engine project. I am now spending more money on it than I did before. And the more money now that I spent on it before is still like the upper echelon of what I can spend on it. So if I bought all this new, there'd be no way I could afford it. So that means that I have to make do with what I can find. And use whatever combination of fittings and adapters is sensible. Let's see. Hernandez tried to build an Alcubierre drive. I'm not sure how you'd build an Alcubierre drive. I don't think we've figured out the requisite physics to try and build an Alcubierre drive. But if you've discovered either an infinitely long rotating cylinder or you have discovered negative energy, please let me know. I would like to talk to you about a position with Charlie Garcia Systems as our new warp drive engineer. I think that's the end of chat. What do I do when I'm trying to think of ideas for my project? I have a problem with coming up with ideas for my projects, namely that I have too many of them, and I do more projects than I have time for. For example, I have 3 3D printers sitting in that corner of my workshop that need to be put back together after the move out to Colorado, that are just kind of sitting there. But yeah, no problems coming up with ideas for my projects. I kind of think that's as far as we can go today, because I don't have any of the shielded wire cabling I need to wire these up, and my soldering iron is dead, so I can't make any. And I don't have any NPT tape, sorry, PTFE tape, so I can't put stuff together and test it at pressure. I do have... This is my little pressure tank from my RCS project, with this cute little regulator on it. I have the big SCBA tank that I'm going to use with my real liquid engine, but I don't really want to start testing on a tank that big just in case something bad happens. So I kind of think we're as far as we can go. If there are any last questions, I'll answer them, and then I think I will call it an evening. Thank you all for joining me. Would I like to fly my engine? I would love to fly my engine, but first I'd just like to build my engine. Can I share the schematic that I am assembling? Yes, in fact, it's already shared. If you go and watch Liquid Rocket Engines episode 7, it is up there. And for the next live stream, I'll try and have some more media put together so I can talk better about what I'm doing. I don't know what the Lab Padre map is, so I would guess that no, I'm probably not on it. When did I build my first liquid rocket engine? I built my first liquid rocket engine as a freshman in college, under the guidance and supervision of a grad student in college, for the sake of winning a bet. So probably not your normal experience with building liquid rocket engines. Okay, I think that's about everything we can do here. Thank you all for tuning in. It has been a ton of fun.